Hi everybody, nice to meet you on this webinar. So today I'm going to talk about generative AI for cybersecurity. First of all, let me introduce myself. So my name is Farah Jemili. I have engineer, Master of Science and PhD degrees in computer science. My research topics include artificial intelligence, intrusion detection, big data analysis, and cloud computing. I am an associate professor at TZCOM University of Sousse, Tunisia. So the agenda of this presentation is as follows. First of all, cybersecurity context, then today's challenges and issues, then research pillars, comparative studies, contribution, and finally conclusion and perspectives. So let me start by the context. Nowadays we are going through the most important communication technologies. Among these technologies, social media, SMS text messaging, email marketing, direct email, blogging, voice calling, video chat, video marketing, live web chat, and virtual reality. And these technologies produce 2.5 exabytes of data each day, and this number is only accelerating with the growth of the Internet of Things. The increased use of connected technologies in Industry 4.0 context makes the smart manufacturing systems vulnerable to cyber risks. Cybersecurity experts said that the damage related to cyber attacks is projected to hit $8 trillion in 2025 and will grow to $10.5 trillion by the end of 2025. So let's have a look at 2020's biggest attacks and how much did they cost. So as you can see here, Equifax, Yahoo, Uber, and WannaCry have lost $100 million due to cyber attacks. Among these attacks, denial of service, distributed denial of service, network scans, port scans, and botnets. 81% of victims did not have a system to self-detect intrusions. And in 2022, the average time to identify a breach is 207 days, and the average time to contain it is 70 days, totally 277-day breach life cycle, which means a drop of 10 days compared to 2021. Cybersecurity experts said that cyber attacks happen once every 39 seconds in 2023, and global AI in cybersecurity market is predicted to grow at 35% during the forecast period, with the market size reaching $31.2 billion by the end of 2024. Now let's have a look to the industrial artificial intelligence ecosystem, which defines a sequential thinking strategy for developing transformative AI systems for industry. It is composed of 4 main pillars: impacts, transformative system methodologies, enabling technologies, and challenges. So I'm going to explain the enabling technologies level for this ecosystem. The enabling technologies is composed of data technologies, which enable successful acquisition of data. Analytics technologies convert data from critical component into useful information. And the platform technologies include the hardware architecture for manufacturing, data storage, analysis, and feedback. And operations technologies refer to a series of decisions made and actions taken based on the information extracted from data. So let's have a look to some real-world examples of AI solution in cybersecurity context. The first one is Cylance, which is a software that uses machine learning to detect and prevent malwares from penetrating network through endpoints. The second one is automatic exploit generation, AEG, which can find and determines whether the bug is exploitable or not. If found, the bot autonomously secures vulnerabilities. The AI2, which is an AI platform that predicts cyber attacks by continuously learning input from human experts in real time. And IBM's Watson for IoT, which is a network-wide analytics platform that are able to predict in real-time failures and recommend maintenance based on connecting network component conditions. So based on this context, here are today's issues and challenges. The first issue is how to collect and store massive data with different sizes and types. This question or this issue has to do with data collection, storage, and pre-processing. The second issue is how to process streaming and massive data. This question has to do with streaming, big data fusion, and analysis. And the third issue is how to achieve accurate cyber attacks detection. This question has to do with artificial intelligence, machine learning, deep learning, and generative learning. And the fourth question is how to provide an appropriate intrusion response. This question has to do with decision-making part of AI. So our research has four main pillars. The first one is cybersecurity, the second one is cloud computing, the third one is big data, and the fourth pillar is artificial intelligence. So let me introduce the first pillar. Cybersecurity is the application of technologies, processes, and controls to protect system networks, program devices, and data from cyber attacks. It aims to reduce the risks of cyber attacks and protect against the unauthorized exploitation of systems, networks, and technologies. Cybersecurity technologies is composed of firewall and VPN, access control, and intrusion detection. In our research, we are focusing on intrusion detection systems. So what is an IDS? An IDS is a device or software application that monitors a network for malicious activity or policy violations. It is characterized with 6 main characteristics, which are detection approach, which can be anomaly or signature-based, the protected system, which can be host-based, network-based, or hybrid, the structure of the IDS, which can be centralized or distributed based on agent systems, data source, which can be audit tray, network packet, or system analysis, the behavior, which can be active or passive, and the analysis timing, which can be on the fly or interval based. Now let me move to the second pillar, which is cloud computing. Cloud computing is an on-demand access via the internet to shared computing resources, application servers, data storage, development tools, networking capabilities, and more, hosted at a remote data center managed by a cloud service provider or CSP. So it has different delivery models: infrastructure as a server, platform as a service, and software as a service. It has also different deployment models, can be public, private, community, and hybrid, and different services, which means processing and storage services. Now let me move to the next pillar, which is big data. So what is big data? It's when data can't be processed or stored on a single machine or single program, then it is called big data. It is characterized with its 4 main V's. The first one is volume, which has to do with the scale of data. The second one is a variety, which has to do with the types of data, and velocity, which has to do with the speed of data, and veracity, which has to do with the uncertainty of data. Now let me move to the fourth pillar of my research, which is artificial intelligence. It is the ability of a system, such as a computer, hardware, software, or other devices, to acquire and apply knowledge and skills. It can be machine learning, natural language processing, speech, expert systems, planning, scheduling, and optimizations, robotics, and vision. Machine learning is part of AI that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. It can be supervised, unsupervised, and reinforcement learning. Here is a typical ML workflow. So given a number of data providers, we have as input raw data. The first step is pre-processing step. This step is iterated until we obtain structural data. Then we apply learning algorithm, and this step also is reiterated in order to obtain the best model by fine-tuning the model, by also modifying the hyperparameters, etc. And then when we find the golden model, the best model, which we call the golden model, it is applied on real-world applications. So what is deep learning? As you can see here, when the amount of data is big, okay, the performance, deep learning has better performance than the older machine learning models. So when we have challenges like big data, big compute, deep learning has much more advantages compared to older machine learning algorithms. Here, for example, here a comparative study also between machine learning and deep learning. So as you can see here, feature extraction is part of deep learning, contrary to the machine learning process. And if we consider a simple neural network, as you can see here, it is the only one hidden layer. When we deal with deep learning neural network, we have much more hidden layers, which means better calculations, especially when we have a large amount of data. Deep learning algorithm can be classified into discriminative, representative, generative, and hybrid models. So for discriminative models, we have some deep learning algorithms such as recurrent neural network, convolutional neural network, multi-layer perceptron. For the representative models, we have the autoencoder algorithm. For generative, we have the generative adversarial network, and hybrid models, which are a combination of this type of deep learning. So now this is a comparison between deep learning models. So the discriminative focuses on learning the decision boundary between classes based on given input features. The representative learns a compressed representation of the input data with the goal of reconstructing the input. The generative one models the underlying probability distribution of the input data and generates new samples, and the hybrid one combines elements of both discriminative and generative model to leverage their strength. Now, this is the fuzzy logic, which we have used in our research in order to deal with reasoning that is approximative rather than fixed and exact. So in contrast with traditional logic theory, where binary sets have two-valued logic, true or false, fuzzy logic variables may have a truth value that ranges in degree between 0 and 1. So fuzzy logic has been extended to handle the concept of partial truth, where the truth value may range between completely true and completely false. So here is the process. First of all, we fuzzify the inputs, we apply rules, then we aggregate the outputs, and we defuzzify the outputs. Expert system is part of AI. It is a computer program that is designed to solve complex problems and to provide decision-making ability like a human expert. Also, we have used this expert system in our contribution. So as you can see here, the knowledge base is constructed based on knowledge from expert, and then rules are extracted from the knowledge base, and then interference between the user and the expert system in order to provide the necessary recommendations. So here, a comparative study between cloud providers that we have made in order to choose the best one for our research. So Gartner Magic Quadrant Research 2019 shows that Amazon Web Service, Microsoft Azure, and Google Cloud Platform are dominating the cloud industry. Amazon Web Services, as you can see here, is more mature and present in the market, and provides a computing capacity larger than other providers, but it is high cost. The Google Cloud Platform is low cost for both processing and storage, full access to Google products, but it lacks some services, and relatively new and still in development. Now, Microsoft Azure Cloud, it has data centers in more than 54 regions, more than 200 services, low cost for both processing and storage. It has the best disaster recovery system, and its disadvantage is that it supports mostly applications that are based on Windows. Now, this is a comparative study between big data framework, the most popular ones, so the most popular open source, distributed and fault-tolerant frameworks. So Apache Flink is hybrid, batch and stream processing. Its supported languages are Java, Python, Scala, and R. It has low latency and exactly once processing. Apache Storm is its supported language are Java and Clojure, pure stream processing, at least once processing, and Apache Spark is hybrid, batch and stream processing. Its supported language are Java, Python, Scala, and R. It has low latency, interactive queries, exactly once processing, and streaming. It has streaming with applications, stream-to-stream joins, and it has its own machine learning library, which is ML Spark. So for this reason, for this number of features provided by Apache Spark, we have chosen Apache Spark in our contribution. Now let me move to our contribution, which is titled the Deep Learning Based Intrusion Detection Approach for Mobile Ad Hoc Networks, which has been published in Journal of Soft Computing 2023, which is Quartile 2, Scopus, and Simago indexed. So in this approach, the proposed approach enhances intrusion detection systems for mobile ad hoc networks using deep neural networks. It includes data collection, attack signature generation, and generative learning, and of course attack classification. So first step is data collection. Then we generate attack signatures for attacks who are not labeled, who don't have labels, and then we use generative learning in order to learn from this data, and then we classify the attacks into their classes. So I'm going to explain each step. So data collection, IDS nodes are deployed in a promiscuous mode to collect routing packets and gather data for training. The second step is attack signature generation, which establishes a collection of signature to represent both normal and abnormal behaviors. The files are stored in Azure Blob Storage using hot access mode and replicated across multiple regions. The generative learning model is based on semi-supervised learning, which combines labeled and unlabeled data, and a self-training process based on stacked autoencoder algorithm is used to assign labels to unlabeled data in order to generate labeled data. And this is the third step. And then the fourth step is attack classification. So based on DNN algorithm, attack classification models consists of input, hidden, and output layers with normalization and traffic image conversion performed on the input data. So the loss curve here diminishes and then stagnates, which means that the model has learned and optimized its parameter to a certain extent, and the accuracy curve increases and then stagnates, which means that the model has learned to correctly classify the training data up to a certain level of performance. The model demonstrates effective detection capabilities for normal, black hole, gray hole, and flooding classes, but further improvements are needed for detecting wormhole attacks. So here we have cited our Azure Haji Insight cluster setup. So we have 2 worker nodes and 2 head nodes. Each node has its own characteristics based on the number, the CPU, the memory, the storage, the operating system, and cost. And then we evaluate our Spark with metrics and results. So the input rate of our Spark describes how many events were loaded per second. In our case, 560, about 560,000 events per second. And the processing rate describes how many events were processed per second, which in our case, 55,000 events by second. So to conclude our work, this proposed approach based on generative learning gives good results in terms of accuracy. Here are some ideas that can be developed. So fuzzy generative learning approaches, streaming, processing, and data fusion in the cloud to join streams of diverse data sources, and recommend a system to provide the necessary recommendation and to deal with the detected intrusions. We call this type of ideas active ideas.